So you want to build an electric longboard.
This longboard is mine. Here I have my single 6374 motor attached to my enclosure. Now all of the important circuitry is inside of this enclosure, so in order to show that off, I'm going to take it off now. As you can see, my enclosure is made of ABS plastic with a waterproof sealing. And then I'm going to undo all of the Velcro that's helping to hold these things down. And we can take a look at the components. So before I disconnect any components, I make sure I have my board off. I'm going to disconnect these XT90 connectors, which allow for connection without causing sparks. And by taking all these things off, I can now show off the different parts of my board. So, most importantly is this chip right here. This is called the VESC, and I currently have it to a receiver for a Nano X control, or a controller. That's what you actually hold in your hand, and when you move the thumb wheel on the controller, it actually causes the board to accelerate or decelerate because you're sending out radio controls, which this receiver picks up and then sends to the VESC. Also attached to the VESC, I have a HM10 Bluetooth module here, and that allows me to connect to an app on my phone so that I can read the current vitals of my board, and that would be something like voltage or the amperage of the battery or motor. And I can also limit those things from there. It also gives me things like temperature, as well as rotations per minute, and can be used for speed. Now if we go here, we have the VESC, which stands for Vader Electronic Speed Controller, designed by Benjamin Vader, or Vetter. These here are the motor wires that use bullet connectors to connect through here to the motor. We also have these multiple fine cables that connect to the sensors in the motor. That gives you things like position of the motor and also lets you have the temperature. Now, if you're using a VESC, you actually may be better off using a non-sensored motor. Not only are they cheaper, but it is potentially easier to set up, and that is because VESC allows you to program the startup, and sensored motors are only needed so that you can start up easily. Now, moving on, here we have an anti-spark switch, and all this does is connect to a little button, which you can see here. It uses direct FETs, and it has these FT90 controllers to connect so that you can start the board without causing any sparks. Now if we move on, here I have a battery. This is actually a custom 18650 lithium-ion pack, designed by me. However, it was created by Skateboards on the eSkate.builders forum. The only other significant part here is the motor, and what I'm actually using is the 6374 Alien Power Systems motor. And while I highly recommend Alien Power Systems, the only thing to be wary of is before you order, Alien Power System almost always uses a 10mm shaft on their motors. And motor pulleys almost always come in an 8mm bore size, which means you're going to have disalignment, and that can cause a lot of problems. So, what is better to do is either get a motor kit, something like from Build Kit Boards, for example, or from DIY eSkate builders. Their motors will almost always have 8mm shafts, which make it much easier. You won't have to do any lathe work like I did here. And you will also have a much easier time hooking it up with your motor mount. For example, I had to drill this motor mount out to fit this 10mm shaft. Meanwhile, if I had an 8mm shaft motor, none of that work would have been needed to do, so it would save you a lot of time. I just removed the enclosure by removing the shrink wrap on these motor phase wires and then disconnecting them, which allowed me to remove the enclosure because it's actually routed through a hole here, as you can see, and then that button is here again. So If you come into making an electric skateboard, all the information you see can very easily intimidate you. But what's really important to remember is that it's actually a very simple circuit once you know what you're doing. So the main components are you're going to have your motor. Again, I would recommend a sensorless motor if you're going with a VESC, which is this here. So you're going to have your motor, an anti-spark switch. Now this can be done in a very great length or multiple ways. You don't actually need a complex switch like this. You can use an XT90S loop, which actually allows you to disconnect the just you pull an XT90 connector and that will act as your switch for the board instead of having a push button. You then have the brains of the board essentially, which is your VSC. And again, I have the input from my controller as well as the Bluetooth module going in here. And as you can see right here, this long chip is actually going to be my DRV chip, which controls the entire board. Here are the multiple capacitors, and after that, this connects to the battery here. I have both a charge and an output connection. So this is my output. This connects here. And what that allows me to do is power up the entire board. When you're building these boards, it can be very confusing. And to anyone who wants to start and build their own board, the first place you should go is a forum where you can talk to other people. Now, there's a few different forums, but by far the best one, in my opinion, is eskate.builders. And I'll link that in the description. But that forum actually gives you a whole host of information about everything that you could ever want to do. The founder is actually someone who runs an e-skate company on Loop. He actually is someone who created the Fockbox, which is used by universities worldwide as one of the best VSCXs, or more specifically, the VSC6 at the moment is also being manufactured. Aside from that, there are many different builders, custom builders. For example, Long-Haired Boy is a professional builder, and he's on the forum. So any type of information that you may need, I highly recommend you go to a forum. You can get the help you need, and there's guides to help you learn where to start. And once you get past that phase, it's really just picking your parts, knowing how to put them together, and really working through kind of the bugs that you'll get when you work on projects. I highly recommend doing this project if you would like to learn more about different things such as electrical. If you have any questions about the topics I've covered in this video, please just leave a comment on this video and I will try to respond as fast as possible with detailed information. If you enjoyed this video, I would greatly appreciate a like and maybe even a subscribe.